In the world of AI development, there is this new kind of threat that's honestly pretty sneaky. It's one that can turn your super helpful AI assistant into an unwitting accomplice in its own attack. So today, we are talking about OWASP ASI05, where OWASP stands for Open Web Application Security Project. OWASP ASI05 is also called as accidental attack. So let's set the scene. It's a setup that's becoming really common for a lot of us. You have got a powerful AI agent baked right into your workflow, and a huge part of its job is to write code for you. And to be really useful, it can't just write the code. We are giving these agents the power to actually execute that code, to run our tests, spin up environments, automate all those tedious tasks. It's a massive productivity boost. But there is a catch. And that right there is the heart of the whole problem. It's that moment when that helpful execution turns into a complete security nightmare, all without you even realizing what you asked for. This vulnerability has a name, and it really hits the nail on its head: the unintended command. See, this isn't about hacking the AI itself, it's about tricking it. Officially, it's OWASP ASI05, unexpected code execution. Now, the two key phrases you got to focus on here are manipulated and without explicit intent. The user isn't doing anything wrong. The AI isn't buggy. The whole system is just being exploited by getting the AI to run some nasty code that was hidden inside a source you thought you could trust. And this gets to why this is so scary. It's the sheer amount of power we are handing over to these agents. I mean, they are not just chatbots anymore. They have got the keys to the kingdom. We are talking direct terminal access, control over our DevOps pipelines, the whole build and deploy process, and the ability to just run scripts. This power is what makes them so useful, but it's also what makes this vulnerability so incredibly dangerous. So, what does this actually look like in the wild? Let's walk through a pretty classic scenario that OWASP highlights. This is a perfect example of an attack in disguise. It all starts with something completely normal, a request you or I might make every day. A developer is checking out a new library and asks their AI assistant, let's call it Dev AI, to do something simple. Hey, can you read this documentation on GitHub and just run the setup example for me? It's a classic time saver. But buried inside that seemingly innocent README file, tucked away in a normal looking code block, is this little piece of poison. For anyone who is not a command line junkie, rm-rf is the command to just obliterate files. In this case, all your project logs gone. And the second part, it downloads and immediately runs a script from some attacker's server. It's just hidden there in plain sight. And that one command kicks off this just devastating chain reaction. The AI, just trying to be helpful, runs it. And boom, instantly, any logs that could trace the attack are wiped clean. Then malware gets downloaded, which starts sniffing around the system for things like SSH keys or other secrets. It sends those back to the attacker, and just like that, they are in. And here is the absolute most crucial point: the AI did its job perfectly. It was asked to run an example code from a document, and that is exactly what it did. The vulnerability isn't some flaw in the AI's logic, it's a flaw in our blind trust of the content we feed it. It followed the instructions with a terrifying and very dangerous literalness. Okay, so this goes way beyond just one bad README file. What this really shows is a fundamental shift in the risk that comes with this much automation. This is the automation threat. Think about it. The attack vector could be literally anywhere the AI reads from. Imagine a malicious Python snippet hidden inside a research PDF your agent is summarizing for you. Or maybe a compromised code example that gets pulled in by a RAG system. That's the tech that fetches external data to answer your questions, also called as retrieval augmented generation. The second you connect an AI's ability to read with its ability to execute, the risk just multiplies like crazy. And this spells out why this is whole new class of threat. With our traditional tools, there is always a human in the loop, right? You have to consciously copy a command, paste it into your terminal, and physically hit enter. But with an agent, that action can be totally automatic and completely unintentional, all triggered by a prompt that looked harmless. This makes the breach silent, it makes it fast, and it makes it incredibly hard to trace back to any one human mistake. Okay, so that's the problem. And yeah, it's a serious one, but it's not hopeless. So let's shift gears and talk about what we can actually do about it. Let's look at how to build up our defenses. The recommendations from OWASP are really all about putting smart guardrails in place. First, and this is a big one, never let an AI automatically execute code it just finds somewhere. Second, always require explicit human approval for any sensitive commands. A simple yes or no prompt can literally prevent a disaster. And third, run everything in isolated sandboxes. That way, if malicious code does run, the damage is contained. It's also super important to filter and scan content from external sources. Lock down direct terminal access with strict policies and keep an eye on what's happening, like monitoring for weird network calls or strange file changes. This is all about putting that critical layer of human oversight back into the loop, which really brings us to the core principle here. The number one rule for building secure AI systems. Just because a large language model can execute code doesn't mean it should, at least not automatically. All that power needs control. As we wrap this up, I want to leave you with this question to chew on. The line between a powerful game changing assistant and an unintentional backdoor for an attacker is dangerously thin. And it's a line that isn't defined by the AI itself, but by the guardrails and the policies that we choose to build around it. Thank you for listening.